Okay, students, so like I said, I will not be here today, so I recorded this video to go for 8.5. Just FYI, your homework is going to be a worksheet, so you should have had that. I handed it out on Wednesday, so you should have that labeled for 8.5. Okay, but today basically is going to be looking at problems solving with trigonometry, whether I deal with SOHCAHTOA or also we can look at law of sines, law of cosines. Okay. So what I want to start off with is when we're talking about different types of angles, there's two types. What's known as angles of elevation and then also angles of depression. Okay, so how do we identify those? Okay, well, I'll show you on the diagram below. So it says identify angle 2 as an angle of elevation or angle of depression. So if we look at angle 2, is right here. Okay, what you have to compare it to is, are you elevating up or elevating down? And what I can see is this is my horizontal line, and I'm basically going up from there. So in other words, angle 2 is going to be an angle of elevation. Okay. From there, we can also look at angle 3. So angle 3 is going to be down here. So if the horizontal line is above the angle and it's going down, then angle 3 is an angle of depression. Okay. So it's just basically, are you going up or are you going down? Okay. Good. Okay. So we kind of have those terms. So now what we're going to look for is what's the relationship between either angles of elevation or depression. Okay. So here's what it says. In example 1, how does the angle of depression, angle 1, compare with the angle of blank for angle 2? So what I can see is angle 1 is an angle of depression and angle 2 is here. Okay. Angle 2, remember, is an angle of elevation. So that's why I'm going to fill in there. But then what I want to think is what's the relationship. So what I can see is these are my two parallel lines. Okay, they never touch. Horizontal lines never touch. Okay, and then this is a transversal. So what I can see is they're on opposite sides of the transversal and on the inside of the two parallel lines. So we know angles 1 and angles 2 are alternate interior angles. Okay. And we know from topic 2 that alternate interior angles are congruent. So what we're going to do is in the examples below, we're going to look for, like, given the angle of depression, where's the angle of elevation? Okay. If at any point you need to pause this, feel free to do that. Okay. All right, so moving on. So it says using angles of elevation and depression. It says for a reverse bungee ride, Reagan stands halfway between the two posts. So here is Reagan right here. Okay, she's halfway. So let's just fill this in. So we have the whole thing is 8. This would be 4, and this would be 4. Okay. Then it says 2 bungee cords extend from the top of the post to Reagan's waist 1 meter above the ground. So in other words, okay, the post is here, that's 1 meter above. Okay, and then it says add a 70-degree angle of elevation. How tall are the posts? So in other words, your angle of elevation is here, 70, and we're trying to figure out x there. Okay, so we're going to do what we did before. What I'm going to do is point out this triangle here, so I'm going to highlight it. Okay, so right here, we have this triangle, and this angle is a right triangle. So we can use SOHCAHTOA. So what I'm going to start with is x is going to be opposite to angle 70, and then 4 would be your adjacent part to 70. So opposite and adjacent means I use TOA. Okay, so TOA stands for tan. So you would do tan of that angle 70 is going to equal x, because it's opposite, over adjacent 4, not 8. Okay. So then just cross multiplying, okay, what I can do is I get x equals 4 times tan of 70. Okay. And so then just plugging that in, I would get x is equal to 10.99. Okay, so I have that. Okay. Then from there, what we're going to do is now it's asking how tall are the posts. Okay, we need to look back at our diagram. So right now, I know this part right here is 10.99, but the posts go all the way to the ground. So we have to include this 1 meter here. So I would add. So the posts would be 10.99 plus 1. Okay, and so you would get the posts would be 11.99 meters. Okay, make sure you have units because we're going to talk, because this is an application problem. Okay, so that's it. Okay. Okay. If you want to try this next one, feel free to pause the video right now. Otherwise, you can listen to what I'm doing. Okay. So here's what it is. Okay, we want to draw a picture. It says Nadim is standing 180 feet above the ground on top of a tower. So let's just start by drawing this out. Okay, so you have this tower here. Okay, and Nadim is up here. Okay. Okay, and it's 180 feet. So in other words, this part right here, okay, would be 180 feet. Okay. And so it says he looks down at a tour bus at an angle of depression of 23 degrees. So remember, for angle of depression, what we want to do is we want to draw like a horizontal line straight across, okay? And then the depressing line is going to go like down like this, okay? So in other words, this part right here is going to be 23 degrees, okay? Okay. And it says to the nearest foot, how far is the bus from the base of the tower? So we have a bus here, okay, and the tower's here, okay? You're trying to find this length right here, okay? And we have a 90-degree angle. Okay, so the first thing I want to do is I want to locate that angle of elevation. So what you need to think is this is your transversal, this is one of your paralines, and this is your other paraline. Your alternate interior angle is going to be right here, okay, and that's going to be 23 degrees, okay? So now I'm just going to look at this triangle specifically, okay, so that triangle in there, okay? So now what we'll do is 23 is my reference angle, opposite is going to be 180, and that's going to be my adjacent side here, okay? So opposite and adjacent is TOA, so I would do tan of 23 equals, that's going to be 180 over x. Make sure it's not x over 180. Okay? And so what I would do is cross multiply. So put this over 1. Get x times tan of 23. Okay? Equals 180 times 1 is just 180. And then from there, I'm solving for x. So I would divide by tan of 23. Okay? Divide. And so then your final answer would be just plugging this in your calculator. Okay, and so it says to the nearest foot. So nearest foot is 0 decimals, so just a whole number. It would be approximately 424 feet, and that's it. Okay. We're going to try a little bit harder one. Okay, so here's where it's going to get a little more difficult. Okay, it says an instructor holds a safety rope from point C from a student to rappel from anchor point T. The rope between them measures 61 feet. How much more rope should the instructor let out so that the student can make it to the resting point? Okay, so essentially we're here, we're starting here, and the resting point is at R. So I'm trying to find this part right here. Now, this picture's a little squished, so what I'm going to do is I'm going to pull this triangle on top off to the side. And how I know why I'm using this is because I also have that 61 feet. Okay, so I'm just going to pull this triangle off to the side. I'm just going to do this, okay? Okay, so let's just draw like a rough sketch. So you're going to be like here, okay? This is 61 here, and we have here, okay? So this would be C, this is R, and this is T, okay? Okay, so there's a couple of things I want to point out. It says how much rope should the instructor allow so that the student can make it to the resting point. If you're trying to make it to the resting point, what you're really trying to find is CR. Okay, that's what I'm trying to find. Okay, so what I'm going to do is this, guys. I'm going to see what else I could label in this triangle to the side based upon that overlap. Okay, so the first thing I notice is I can find, and it's very small, this angle Y right here, okay, is this angle right here. And what I see is that the whole thing is 79, and this part down here is 75. So I would just do 79 minus 75, okay? And so that would mean this angle right here is 4 degrees, okay? So now what I'm going to do next is I'm going to think, like, what else could I use? Well, I see that there's the 61 here, okay? If I find this angle right here, then I can use the law of sines to set up my equations. So how do I find that angle? Let's go back to the picture, okay? What I'm going to do is I can see that there's this bottom triangle down here. So this triangle, that's the right triangle, okay? I can see that I have a 90-degree angle here. This is 75 here. I can find this angle right up here by just doing 180 minus 79 minus, oh wait, not 79, minus 75 minus 90, okay? And so when I do that, sorry, I didn't write it down, okay? 180 minus 75 minus 90 is going to give you 15 degrees right here. But now what I can see is that 15 degrees and this angle right up here form a linear pair. So I can find that by just doing 180 minus 15, and so that would be 165. And so what I found is this angle right here is 165 degrees. Okay, so we're slowly getting there. Okay, now I'm going to go to this picture and see if I can set up law of sines. Well, look what I have, guys. I have 165, I have angle 4. I can find this angle up here because it's a triangle. So I could find angle T by doing 180 minus 165 minus 4. And so that would give me 165. So 4, 15 minus 4 would give me 11 degrees. Okay. And now look what I can see. I'm trying to find CR, which is this guy right here. It's opposite to angle T. So I can do sine of 11 over CR is what I'm trying to find. And then the other ratio I have is this part here over 61. So it'd be sine of 165 over 61. And then it's just law of sines. Okay? So cross multiply, you would get CR times sine of 165 equals 61 times sine of 11. Okay. Divide by CR, and so you get divide by sine of 165, you would get this. 61 sine of 11 divides sine 165. And so I would get CR to be, plug that in your calculators, 44.97 feet. Okay, and so we have that. So that one's a little trickier. What I would always do is draw your triangle to the side. Okay, that's the main thing. Okay. Cool. So let's look at this one. So it says, in example 3, how far is the student from the instructor at the resting point? Okay, so like what we're trying to figure out is like essentially this. Okay, if you're trying to figure out how far the student is from the instructor at the resting point, okay, what you really want to do is you really want to find, like, the instructor's all the way at the bottom. So he's at H, okay? What I'm going to do is this. I'm going to find, okay, TR, because that's what like this part right here, okay? And what I can do is I can do the whole thing, TH, okay, minus RH, okay? Okay, so let's just do that. So here's what I have, is I basically have two separate triangles. Okay, I'm going to use the right triangles now to help me out, okay, because I'm also going to use the one above, okay? So you have this first right triangle, okay? You know it's CRH. We know H is going to be the right angle, and we also know that this angle right here is 75 degrees. Okay? We also know from the example above, that this part is 44.97. Okay, and we're trying to figure out RH, so that part. Okay, so what I would do is that's going to be opposite here and hypotenuse. So you would do sine of 75 equals opposite x over 44.97. And so you would get x is going to equal to 44.97 times sine of 75. And so you would get x to be approximately 43.4. So that's the first part. Okay. The next part is going to be finding TH. So TH, I'm still going to use that right triangle. Okay. But now I'm just going to use the bigger length. So you have H is down here. This still here is 75. But now we're extending all the way up to we're all extending all the way up to T. And then this length from C to T is, remember, 61. So then we're now going to try and find this part. So it's the same steps. You're going to do sine of 75, but now that equals y over 65. Okay, cross multiply, you get y equals 65 times sine of 75. And so you would get y equals 58.9 right there. Final step, take this, take that, plug it in and subtract. Okay, and so you would get final answer is 15.5 feet. Okay, so a little more difficult, but still doable. If anytime you're trying to, I would always use the right angles. Okay. Alright, and then this final section, it talks about using trigonometry to find triangle area. So it says, how can you use trig to find the area of triangle ABC? So the first thing is, it says use sine to write an equation for H using C. Okay, so like what I have is I have this as angle C. I know sine of C is opposite over hypotenuse. So opposite here would be H over your hypotenuse is A. But then it says an equation for H. So in other words, I'm just going to multiply A to both sides, and so I would get H equals A times sine of C. Just multiplying this and that. Okay? So I'm going to save that now. Okay? So I know that's your height of the triangle. And now it says write an equation for the area of a triangle. We know area of a triangle is just 1/2 base times height. Okay? If I look at my base is this full length, which is B. Okay, so I would get 1/2 times B. Okay, but then I'm multiplying it by my height. I know my height is that part right there. So it'd be times A sine of C. And so what the equation looks like is I just rearrange a couple things. This is the formula equation. Area equals 1/2 A times B times sine of C. Okay, so really what I need, okay, is you have to be like given angle C, okay, and two sides, which are going to be sides A and B. Okay, so that's what I'm using. This is a formula you got to memorize. So there's a lot of formulas. Okay. All right, cool. So here's what I'm going to do. Okay, I'm going to just basically use that to help me find the area. So it says, what is the area of FEG in the triangle? The lengths of the sides of G and H are 3 and 4. So let's fill those in. So this here is 3. This here is 4. Okay. And then the angle I'm using is this angle right here. Okay. So what I'm going to do is let's just call that, okay, we're going to do area equals 1/2. It's A times B. So the two sides are going to be 3 times 4. And then we do sine of that angle. So sine of 1/16. And so you're just plugging that in. So you get area equals, plug that in. That would be 6 times sine of 1/16. And so you would get A to be approximately 5.4. And then remember, we're talking about area, so it's still centimeters, but it's squared for area. And yes, you need units. Okay. So that's pretty much it for this lesson. Okay, so basically setting up problems using trig. Okay, for your homework, okay, that's going to be the worksheet I handed out. It's the lesson 8.5 worksheet. Okay. That's going to be, I'm going to check it in on Tuesday. Okay. Okay, and then if you do finish that worksheet, I also do have the topic 8, okay, practice problems. Okay, so that packet that I handed out, that's going to be due on the day of the test, so due Wednesday. Tomorrow, you'll just work on that packet, or along with if you need more time on that worksheet, okay? But then our test is topic 8 test on Wednesday. Okay, so there's all your dates. Okay, so feel free to sign off, but thanks for listening. Bye, guys.